Among DARPA's strange heavy lift machines, Avidrone's entry looked almost ordinary. It was an electric helicopter with one main rotor for lift and a tail rotor for control, but the entire aircraft, including its battery, weighed less than 30 pounds. DARPA still required it to carry at least 110 pounds for 4 nautical miles, release the load, and fly 1 more mile. That made the familiar layout a severe optimization problem. The blades, frame, electric drive, battery, and belt-driven tail system all had to do more with almost no spare mass. The question was how far Avidrone could push it before the first ordinary-looking component became an extraordinary limit. On day 4, Avidrone loaded 112.4 pounds beneath the 29.3-pound aircraft. That was nearly 4 times the helicopter's own weight before it had moved an inch. Once airborne, the design's apparent simplicity became its advantage. The large main rotor moved air efficiently, while the tail rotor kept the electric drive's torque under control. For loaded miles passed without a visible struggle. The helicopter landed, released the plates, and launched again. It completed the final unloaded mile with the same precise control. Nothing dramatic happened, and that was the achievement.
Oh, yeah.
Oh, he's going to put it right in the center. Now you're just showing off.
Oh, yeah. Well, you got to do it. You got to do it.
So there you go.
Yeah, big high five there. Big high five, a big hug, a big handshake. That looks to me like a successful run and a new leader.
The completed 3.84 run put Avidrone in first place, with the 4-to-1 target suddenly close. Avidrone could have protected its completed run. Instead, the team added weight and launched again. The extra fraction looked small on the scoreboard, but mechanically it reached everywhere.
Let's take a look and see what happens here in the replay. They lift off. They are in the air. They're carrying the weight. And we see a little...
Structural failure on the rotor blade.
Structural failure on the rotor.
Yeah.
More payload demanded more lift, increasing blade bending, drive torque, and the force the tail rotor needed to oppose. A main blade flexed or failed and struck the tail boom. The attempt ended almost as soon as it began. The smooth run had already consumed most of the helicopter's structural margin. Avidrone still held the lead, and it still had aircraft available. The next warning would arrive as a sound only the team could hear. On day 6, Avidrone returned with another aircraft and pushed beyond 4-to-1. Seconds after liftoff, the payload separated and the unloaded helicopter climbed away.
Yeah, the automated release system popped it off, maybe.
This is Avidrone, and we can tell you right now they are at 4.16. They were until they ejected some weight. That was 122.4 pounds on a 29.4-pound vehicle.
From the broadcast booth, the release looked like another failure.
It was actually that. So they have a belt-driven system, and that belt was not tight. It was skipping. And they could hear it out on the flight line. We couldn't hear it here, of course, in the broadcast, but they could hear it on the flight line.
The team had actually heard the tail rotor belt skipping and deliberately dropped the load to save the aircraft. The release system had turned an ominous sound into a second chance. They tightened the drive, reduced the target slightly, and launched again. This time the load stayed attached.
And they're at 4.02 on the payload to weight ratio, so history possibly be made here as we've got a scoring run underway.
Oh, no.
And I gave them the old announcer jinx.
Looks like the tail rotor stopped functioning and we lost yaw authority.
The tail rotor had lost authority. Without enough counter torque, the body spun, the aircraft crashed, and the battery burned. For the final day, Avidrone installed a new belt and a stronger mechanism. The team used warm-up flights to seat the belt, then checked and retentioned it before loading the aircraft. There was no reason to protect second place. Avidrone was still first, and only a completed 4-to-1 course could unlock the full grand prize. The final target was 4.05. The indicator turned green. This one would count if it completed the mission.
Yeah, they are climbing to that 100-foot altitude. They'll need to do that within the first half mile, and we've seen them succeed at several runs. Oh, the tail rotor again.
Oh, my.
They struggled with the tail rotor. The tail rotor was slipping. They said they were going to redo the belt. They were going to make it stronger, and they were going to go for it. And it seems like that repair was insufficient to the task.
The strength and drive still could not hold the tail rotor under the added demand. Avidrone came down without completing the course, and nobody else crossed 4-1 either. That left the quiet day for Run at 3.84 on top of the final board. Its first-place finish earned $1.25 million in prize money.
Along with MTech, they finally both destroyed their last aircraft, attempting that 4-1 ratio, which was amazing. Please join us in a round of applause for $1.25 million for Avidrone. Please come on stage to receive your award.
The final aircraft still had one more destination.
A really interesting event that the museum has allowed us to do is actually put the winners' aircraft here on display for the challenge. So up to them on how long they want it to stay. And I was just talking to the team, and I think it's really appropriate that in a museum with beautiful aircraft, they didn't see what it took to get to that. They didn't see all the crashes. They didn't see all the work, the flight test. We're actually going to keep their final broken aircraft on display.
Keeping it broken made the whole story visible. Avidrone never found the last sliver of margin beyond its winning run. But its 29-pound helicopter made a familiar layout carry nearly 4 times its own weight through the full course. The score records what worked. The broken aircraft shows what it took.